Good afternoon. My name is Susan Doyle and I'll be your facilitator today on behalf of Lean Construction Ireland. I would like to welcome you to Lean Construction Ireland's 41st webinar, the topic of which is the engineer's role in a collaborative approach to lean design. If you have a question, please type in the question box and we will ask Stephen in the second half of the webinar. If there are any questions that we don't get answered during the webinar, we will follow up by email afterwards. The speaker for today is Stephen Smalley from Design ID. Stephen has a degree in structural and civil engineering and is regional director at Design ID. Stephen is passionate about lean design and has led the engineering on notable UK and overseas projects and has given talks to the Institution of Civil Engineers, I/D, Concrete Society and St Petersburg Government. He is guest tutor at Queen's University Belfast and was runner-up Young Structural Engineer of the Year. I will now pass you over to Stephen to begin his presentation.
That's great. Thank you, Susan. Thanks very much for the introduction. And thank you also to Lean Design Ireland and also to support from the ICE as well for the invitation to present and to talk in this webinar as well. So, as many of you may have heard, I'm going to talk about, well, today a targeted and collaborative approach to carbon reduction. So the SDG, or the Sustainable Development Goal target dates, they're very ambitious, and really the next, between now and over the next 10 years are critical in negating the tipping point of our planet. So as a practice, Design ID, we've recognised that. We've signed up to Structural Engineers Declare, and we're committed to making an impact to reduce the climate change as well. So part of the reason why I'm here today and giving this webinar is to sort of talk through some of our experiences, some of the experiences we've got about where we can introduce lean design and carbon reduction, and then take you through a few project examples at the end. So I'm going to talk today for about 40 minutes. I'm going to go through a very quick introduction to the SDGs. A little bit of sort of a presentation of carbon in numbers, talking about some of the carbon savings and initiatives, and then to really run through a few project examples to see where we've applied the principles of lean design. So what is lean design? Well, it's not new technology and is a mindset of lean design. So it's about getting into the mindset of thinking about carbon reductions. It's borderless, it's not code restricted. So everything I'm going to talk about today is not about manipulating or actually reducing design codes or working outside of design codes. It's within design codes, but it's just really looking at a leaner way of design. There are stumbling blocks, and I'll talk a little bit about those. It's something that everyone can do, and it can happen now as well. So any project that you're working on, you could go away and actually look and see what potential carbon reductions there are that could be realized, and this can happen any time in the sort of project conception, the project design, or actually the project construction stage as well. But one of the big things is it really needs to be unlocked by early collaboration. So the crisis of climate breakdown and biodiversity loss are two of the most serious issues of our time, and one of the greatest freedoms is how we react to things. That was quite a nice quote by the artist there, Charlie Maxey. So react to things is exactly what we've done as a practice. We've signed up to Structural Engineers Declare. And there's quite a big mantra here that's sort of that they talk about in terms of addressing the climate emergency. They recognise there's an issue there. They've said that the research and technology exists for us to begin that transformation now, but what has been lacking is the collective will to actually go about this and actually realise some of these reductions. One aspect of the UK Structural Engineers Declare section that we've particularly aligned with is where we're seeking to actually raise awareness of the climate and biodiversity emergency, and that there's an urgent need for action amongst our clients, collaborators, and supply chains. And again, that's part of the reason why I'm very pleased and excited to have been invited to talk at this webinar today. So an introduction to the SDGs. Well, I don't know if, how many of you are familiar with the SDGs, the Sustainable Development Goals by the UN. There's a couple of apps there on Apple and Android where it goes into a lot more depth about them, or is the website there, www.sdgsinaction.com. So if you want to, after this presentation, have a flick through those and it'll take you in a bit more detail about what the SDGs are and what they mean. They're basically broken down into 17 separate goals, and really they all align themselves with achieving goal number 1, which is to get to a point where we've got no poverty throughout the world. And there's lots of different goals and lots of different ways that we're actually working through to get there. Will Arnold from the iStructD has actually very nicely categorized these into really 4 main categories, each one of these 17 sustainable development goals. The one that probably affects, I'd say, a good majority of you here in the audience today would be the down in the bottom right-hand corner about a better built environment. And there's the SDGs that actually align themselves with that. But interestingly, all of these SDGs really focus themselves around target number 17, which is the need for partnerships to be able to realize these goals. So what about carbon in numbers? So just a very quick sort of skip through these. This is slightly out of date, this data, but I think generally it's very reflective of where we are now. Around about 39% of energy-related CO2 emissions are by the building and construction sector. A little under that percentage is from transport, and then you've got other industries there as well, and other sources of CO2 emissions there as well. So you can see that we're actually quite a big part of a very big problem in the construction sector. So what about carbon savings and initiatives? Well, there's 6 main, I suppose, categories for where we can look at carbon saving initiatives. The first one is don't build refurb. Don't go out there and start building new buildings, new infrastructure, but actually try and bring back into use existing building stock, existing infrastructure, and actually just look to repurpose existing buildings. Where we can't do that because the building grid really doesn't suit the use of the building, for instance, is to actually look at reuse of, say, the foundations. So actually take the building down, demolish it, but reuse the foundations, and actually look at ways that we can actually recycle the materials that are coming out of that building. So it may be, if it's a concrete frame building, actually look to crush it, crush the material, and try and reuse it elsewhere within the new development. Design efficiently and design for optimization. I'll come on to that in a little bit more detail. Design with low carbon materials as well. There's lots and lots of research into brand new low carbon materials such as graphene and other futuristic materials as well. But actually, it's not just that. It's looking at the likes of timber, for instance, and actually things like cement replacements as well. But it's not using those as sort of, yes, we could do that, but actually bringing those materials into the forefront of our designs. Interestingly, it's looking at design for deconstruction and the ability to recycle. So even if we do have to design a new building, a new bridge, a new piece of infrastructure, that we actually consider that after the life of that building, if it can't be reused, that it can actually easily be deconstructed. So as a practice in design ID, if we're looking at steel frame buildings, we tend to avoid the use of welding, for instance, and go for bolted connections, where it would be much easier to actually take the components of the building apart and reuse them. And one of the big ones that I'm particularly passionate about as well is the production of detailed and accurate handover information. Again, I'll come on to that in a little bit more detail in a few slides' time. But for us to be able to achieve all of those 6 points, there is really only one way that we can do that, and that is by collaboration. We can only realize the big wins of lean design by collaborating with the likes of our fellow peers. So when we're looking at knowledge share between other engineers and other disciplines, looking at making sure that we actually collaborate with our clients as well and with the end users, and actually going as far back to looking at collaborating with the likes of the funders and the various stakeholders who are involved in that building to make sure that it's meeting their requirements, but that we're not over designing as well. So lean design and design loads. Here's a selection of some of our finest design ID staff here, photos of them demonstrating what various magnitudes of design load, of live load, equate to. So the square of paper that's on the floor represents 1 square meter of floor plate. And you can see the amount of people that it takes to stand on that 1 meter square of floor plate to realize the potential imposed load, live load that we design a building for. So you've got 1.5 kilonewtons a square meter there, which is your typical sort of domestic live loads, going through to 2.5 kilonewtons, which would be, say, a multi-story car park, and then all the way up to 5 kilonewtons a square meter. And we also go beyond that as well, up to 7.5, 10 kilonewtons a square meter as well. But what's really interesting is that quite often, for instance, in a commercial building, we're asked within the client's brief to design the floor plate for 5 kilonewtons a square meter. And you can imagine that within a commercial office space, how often would you cram that many people into 5 kilonewtons a square meter? So really it's about interrogating the brief, interrogating the design loads and saying, do you really want us to design that building for that magnitude of load? Because 2.5 kilograms a square meter would be more than adequate for a commercial office space and actually for the future use of the building as well. One of the big misnomers, I suppose, is the fact that if you want to achieve flexibility and adaptability of a building, that it requires high design loads, long columns, long span column free spaces. That really isn't the case at all. Flexibility and adaptability, it ties in with lots of other things. It's maybe about well-placed columns. Commercial buildings is about considering a well-placed and regular grid, tying it up with ceiling, with the ceiling grid, with your mullions, within your curtain wall zone as well, and also looking at different maybe tenancy splits within that floor plate, and making sure that you could accommodate those different tenancy splits within your current design. So it's not about creating big, long span column-free spaces, but it's about well-placed columns. And again, as I mentioned before, it's not about high design loads either, because high design loads will just add cost to the project, and they don't really add to the flexibility or the adaptability of the building. So one of the big things that we focus on within Design ID as well is lean design and design unity. And what I mean by that is how utilized structural members are within a building. And it's quite staggering actually that a piece of research that was done there realized that the average member utilization within a building, so the average column and beam and floor plate and foundation, quite often barely reaches 50% of its overall design load. And that's really quite a level of over design as well. There's lots of things that are tied in with that. There's contingency. Again, there's looking at sort of the over specification of floor loads as well. So really that's a big focus for us to make sure that we're designing to, as best we can, a unity of one, getting the design capacity of the element as close to the actual load that's going into it. And don't forget actually that the design capacity of a building, of an element as well, is if you're following the design codes, there's already factors of safety in there, and those factors of safety are there to actually cover things such as lack of fit or maybe slight tolerances on site, and maybe very local increases in design loads as well. So you're already including 50 to 60% increase in the design loads or decrease in capacity when you're looking at the actual design of a member. But there are stumbling blocks, and I mentioned those at the start. And unfortunately, we live in a very litigious society that is driving PII higher. So there is a reluctance, or there is a change in nature that we need to go through to actually say, we need to design much more efficiently and closer to unity, and not to be too scared about the fact that that there could be issues where we'd be sued, or there could be problems there as well. But that really is a change in nature, and I think that really has to come about with a lot more transparency in the design process. Last minute changes as well, and it's really unfortunate that we go through and we have to design knowing that things may change. And maybe we need to look at a culture where we design very, very close to unity, and we actually say, well, if you make a change, then this is the implication that will happen, as opposed to trying to design to accommodate all these potential changes and actually coming up with something that's a relatively conservative design. What links back into litigious society there is the blame culture as well, and it's unfortunate that quite often we live in a society, we work within an industry where there can be, the sort of people do point fingers and say, well, if something's changed, why is that member increased? The cost is going up. So, quite often we design to sort of say, well, we don't want to get caught up in a blame culture. Lack of collaboration as well. So as I said at the start, if we don't necessarily fully understand the client's brief and the stakeholders that are involved in the project, then it's difficult to design an efficient building. You're designing for something that you're not too sure about. So again, you make it a little bit more conservative. So that's where we really need to focus on collaboration within our industry. And there is a lack of creative and lean thinking as well. So, we need to work together within our own industry as structural and civil engineers. We need to knowledge share, to share some of that creative and lean thinking that we've been going through, but also to learn off other industries and to learn off our clients, to learn off contractors, for instance, that there are other ways to build things that are maybe more efficient, and we need to bring those into the design process. And then one of the other big things is contingency on contingency as well. So we go ahead and we'll design something that is, say, 60%, 70% utilized. It goes out into the cost plan. Within the cost plan, there's another contingency. So straight away, you're adding up huge amounts of contingency within the design and construction process. So again, these are all sort of culture changes that we really need to try and change if we're going to make such a big impact on the reduction of carbon within our buildings and within our industry. So trying to show diagrammatically what that means, well, that cube of concrete there represents 150 mil concrete cube of normal OPC cement concrete, and those party balloons there represent a magnitude of CO2 emissions associated with that. If we then look at the same cube of concrete, for instance, and we look at things like cement replacement, so 50% GGBFS, or actually looking at making reductions in those very carbon hungry concrete components, then there's another reduction in the amount of CO2. But interestingly, the third cube along is actually looking at 20% reduction, for instance, in the use of material and actually performing a much more lean design. And again, there's quite a big reduction in the amount of CO2 that we've got there. And then the cube on the very far right there is timber, which is, you know, sort of deemed to be maybe one of the ultimate zero carbon construction materials, or actually carbon negative construction materials when we consider things like sequestered carbon, which is the carbon associated that's taken out of the atmosphere by that timber, that tree growing. But again, there are stumbling blocks to material replacements as well. So the image on the left there is when we're looking at things like steel recycling. You know, how do we control the quality of that steel that we're trying to recycle? So it's maybe about looking at things like chain of custody, very similar to what there is within timber, to say what's the quality of that steel and how can we reuse it and how can we be certain of its material properties, such as strength. When we're looking at things like 50% GGBFS as well, you know, GGBFS or cement replacement concretes maybe take a little bit longer to actually reduce to reach design strength. So there's the potential that there are sort of program implications. But actually what we need to do is we need to bring these materials further into the design process, so that actually when we're developing our cost plans and we're developing our programs, that these are all factored in at the start, so that it's we've got buildings and structures and infrastructure that's commercially viable by using cement replacements, steel replacements, and that's actually already factored into the program. And also maybe looking at dictating to supply chains as well, carbon reduction by actually using performance criteria within tender documentation. One thing that we have in Northern Ireland, for instance, is the Building Regs Part F, and it's conservation of fuel and power. And we have something called NZEB, which is nearly zero energy buildings. And what's really unfortunate here is actually there was a piece of legislation that came out quite recently that said that if you meet the existing building regulations guidance and relevant government procurement policies, then your building can be deemed to be nearly zero energy build. It can be a nearly zero energy building, and that's really unfortunate, and that's really not the way that things should be going. We shouldn't be looking at reduction in laws and relaxation of laws. We should be looking at tighter targets and really keep lifting that benchmark that we're aiming for. We need to maybe include things like carbon scoring or carbon reduction targets within the tender scoring as well. So quite often within the tender process, we're all very used to looking at sort of value engineering processes, but why don't we also look at carbon reduction processes as well? And what's really interesting is that, when we're talking about lean design and we're talking about the minimization or the reduction of material use within a building, within a project, that material reduction more often than not leads to cost reduction as well. So again, as I said before, it's maybe looking at introducing material use and carbon benchmarking at design stages. And I'll come on to that in a little while when we talk about how we actually measure those. I mentioned there earlier that I'm very passionate about O&M handover information as well, and the use of BIM. If we have to design a new building, and I talked there about, point number one should be that we should reuse existing building stock, then we should be producing clear, accurate handover information now to allow these buildings and structures and infrastructure that we're constructing and designing now that can be reused in the future. And the only way we can do that is to have very, very accurate as-built information. Maybe bring into that what the actual component utilization is, so that if you find that there's an existing building that needs to be reused and repurposed in the future, someone can look at it and say, well, actually, there is a bit of residual capacity in the foundations, there is residual capacity in the columns, and we can increase those design loads slightly to accommodate a change of use. It's about having a clear design philosophy as well, and clear material specifications, so that it's very obvious to someone picking up the O&M manual further down the line exactly how that structure and that building is working, how it's stabilized and where the load paths are. Looking at clear design loads, making it very clear what the design loads are for that building. As I mentioned before, clear safety factors and utilization factors, and also looking at foundation loadings as well. So one of the other aspects of buildings that we come up against when we're looking to reuse it, what you can see visually and test above ground may be relatively simple or relatively straightforward to bring back into use, but what's in the ground is not obvious what's been put in there, and it's not clearly visible, and you can't go in and easily measure what's there. So it's about producing very clear foundation loading information, so it does increase the ability for the foundations to be reused. Statements of adaptability and flexibility as well, and that links in again with clear deconstruction statements and how we would foresee the building now being potentially recycled in the future. So it's not designing for the here and now, it's actually designing for the future use of the building and producing those statements that will allow someone else to actually consider how the building or how the components of the building could be reused and adapted in the future. So what does all this mean? What is the scale of impact of all of this? And this is quite staggering. If you're, as a person per year, if you do all of the kind of fashionable carbon reduction things that are out there at the moment, you know, stop eating meat, stop drinking beer, stop jumping in your car, stop flying so much and things like that, as an individual per year, you can make around about 2 tons of carbon reduction if you go for those initiatives. As a structural, as a civil engineer within the design process, bringing on the principles of lean design, reducing the material use in a building by say 20%, and I'm not talking about sort of major changes, just looking at that unity factor that's there as well, designing much closer to a unity of one, looking at realistic design loads. As a engineer per year individually, we can save up to 200 tons of carbon. That's an absolute staggering amount of carbon that can be reduced. And that's really why I'm so passionate about the principles of lean design as well, because that really is a huge magnitude of difference that we can make. As I said before, we can only do that through collaboration, and that's part of the reason why, as I said, I'm glad to be presenting this webinar today. So when we look at lean design, we look at sort of how do we measure carbon reductions within Design ID using some of the data that's out there by the ICE, the iStruct. It is possible to actually calculate the amount of embodied carbon within your building. So something that we do in Design ID is that we actually look at the various types of materials within a building and say, well, okay, if you design the building in concrete, this is the amount of embodied carbon. If you design it in timber, this is how much it is. And actually display that graphically, so it's very, very transparent and clear how much embodied carbon is associated with each of those different materials or frame types. And then it becomes much easier to actually look at optimization. It becomes much easier to benchmark the carbon within the building as well. And it actually becomes much easier to actually measure what the potential savings are by the various design decisions that come about. So once we've done that initial embodied carbon calculation, that happens right at the very earliest stages of the project, you know, as far back as when we're just considering whether our building should be a 9x9 grid or a 7.5 by 7.5 grid. That's when we start this carbon calculation process. Once we get to the point where we know what the kind of benchmark embodied carbon is, we then measure that against a database of, say, other buildings, for instance, how much carbon would typically be associated with a commercial building, a 9x9 grid, 5 stories. We can then see where we compare to that. And then what we do from there is we then sort of create interactively a chart that says, if you then make any further design decisions from there, this is what the impact will be on embodied carbon. So if you change the column grid, you may be looking at a reduction in embodied carbon. If you change the floor depth, if you squeeze the floor depth because we need more services zone, it increases the weight of the structure, and this is the implication on that. So again, it becomes very transparent what each design decision during the design process will do to the embodied carbon in the building. And then what we do is we input that into a sort of final spreadsheet or final kind of infographic. Infographics are great because they really are very easy to read and they demonstrate exactly what the embodied carbon could be in the building. And then we fit that into the scores kind of range there, where we can talk almost like the energy efficiency or the embodied carbon efficiency of the building. Very similar charts that you'll see on things like kitchen appliances when you go into the likes of Currys to go and buy a new fridge. So that's a little bit about the principles of lean design and a little bit about the sort of our thoughts on carbon savings and initiatives as well. So I'm just going to go through now for the next sort of 15 minutes or so project examples and really show you 3 project examples where we've applied different principles of lean design to come up with overall reductions in body carbon associated with meeting the client's brief. So the first building here is a building in Belfast. It's the Weavers Court Business Court as well, a business district. It's a series of, I guess, sort of anywhere between startup and small enterprise businesses that can come in and rent different floor spaces within different buildings within the business park here on the edge of Belfast. Doherty Architects were the architects for this, and we were the structural and civil engineers. The project brief was to provide something like about 2,000 square meters of lettable commercial space on the footprint of this existing building. This is within the old linen weaving district of Belfast. The building that's shown there is one of the old legacy buildings from the previous use of the site. So what we said is, why go in there and actually demolish that building and build brand new? Why can we not look to see whether there's ways that we can actually repurpose the existing building and bring it back into use? So we did a bit of desk study and we realized that the building was originally constructed in around about the mid-1800s. We could visually see what the structure was. We could go in and take measurements. So what we did is we undertook a very extensive desk study to work out exactly what condition the building was in. We then undertook a series of load testing as well. So we actually loaded up areas of the floor plate, we measured the deflections, and we actually saw how the building would perform with various amounts of effectively live load onto the building. And what was really interesting was we found that the building performed adequately for the loadings that would be associated with a commercial office space, and actually the integrity of the structure was very good, with some minor repairs, some repainting, some more fire protection, and enhancements to the envelope as well. So actually enhancing the thermal envelope as well, changing the windows. We were actually able to bring that building back into use. And what you can see there is some photos through the floor plate. What you can see on the left-hand side of the building, past the brick wall there, is the existing building. And what you can see is on the right-hand side is the new building, the new structure, steel frame structure, precast concrete floor planks, that was actually designed and built to butt up against the existing building. And what was great is the architect had the vision to actually, to try and hold on to some of those really nice features, the nice brickwork, not to hide it, but to actually expose it within the project. So what did we end up with? I think arguably we ended up with a fantastic building. The floor plates from the existing building was brought back into use. Any additional floor that was required was actually provided by a new, very lightweight structure that actually wrapped around the existing building and actually just frames the existing building there. So what we did on that was we brought back into use, we reused the existing building, and also some of the softer aspects is that we maintain some of the heritage of Belfast there as well. And I think the architect has done a great job in very subtly framing out the existing building and maintaining a lot of the existing features of the original 1800s building. Another building, another different type of structure. This is for the University of Buckingham. It's actually in Milton Keynes. It's one of the main access roads to the Milton Keynes Hospital. Phil and Mawson were the architects. We were the structural and civil engineers. And the brief there was to provide a new clinical teaching facility right at the very entrance to the hospital. So it's a real sort of, had to be a very striking building and actually set the scene for the rest of the hospital campus there as well. So what you can see is we've got the new building there, and we've actually got in white there. What you can see in sort of the sort of rusty brown colour there is actually a lecture theatre that spans out from the footprint of the existing building. So when we looked at that originally, the architects, the image there was the architect's aspiration, or that was their brief, the type of building that we wanted to achieve. For those that know Milton Keynes, it's absolutely jam-packed full of roundabouts, and there's a lot of roads around there, but actually there's a really fantastic redway, what they call the redway system as well. So the whole network of cycle paths, that means you can get from one side of Milton Keynes to the other without actually having to go onto a road as well. And one of those redways was running right across the front of our building. So what you can see there, framed in red there, is this is a side elevation of the building, and that's actually the side of the lecture theatre that was shown protruding beyond the footprint of the main building. And again, what we were very close to there was actually the hospital access road as well. So that was a very, very highly utilised main access artery road into the hospital campus. So when we looked at how we achieved that, the problem is that I guess when the QS looked at this at first and said, well, if you're going to do a cantilever, you know, it's going to be perceived additional cost, additional program, additional complexities. So actually the easiest way to achieve that is to not do a cantilever at all, but put in a row of columns and a row of new foundations there. The problem is that that would actually water down the sort of architectural look of the building. And there were environmental considerations and there were buildability considerations with doing that as well. So the first way to achieve that would have meant that to do the new columns, we would have had to put new foundations in. New foundations so close to the redway, if we're going to maintain access down the redway, would have involved more temporary works that would have needed to have been installed. The temporary works would have added cost to the building, and it also would have added material use to the building as well. The other option is we don't do temporary works, but you actually straight away close the redway, dig a big hole in the ground, fill it full of concrete, put the new columns in and achieve it that way. Now, what's interesting in some of the softer aspects of considering climate change within designs is that actually a lot of, you know, the redway was highly utilised. It was utilised by cyclists, and quite often getting into the habits of bringing out your bike takes time. So it takes time to develop that habit. So if you go ahead and you close the redway, you're actually breaking people's habits. If you break the habits, they are going to jump into the car again. They're going to find alternative, maybe more carbon-hungry methods of transport. So actually, you ended up bringing more cars onto the road, and you're causing more problems, particularly to that main hospital artery road or the access road there. So we said, no, we don't want to do any of that. What we will do is we'll actually look at very early on and what the implications are for the building. And what we actually came up with in the end was what you can see here is a transparent view of the envelope of the building. And what you can see in red is the structural skeleton in behind there. So a steel frame building. So what we actually ended up doing is we said, well, let's use the form of the building. Let's use that big depth of the lecture theatre to create some very, very efficient structures. So what we did is we actually provided trusses, steel trusses within the kind of cheeks and the face of the lecture theatre there. So we knew that we could achieve the big cantilever span there by actually utilising a full depth truss. Full depth truss became very, very efficient. The diagonals that we put in there would have only have been the columns that would have gone in the ground anyway. But by using a truss with the top and bottom chord, it meant that we could actually reduce the size of the steel beams associated with the top and bottom chord of that structure. So what we ended up with was actually a more efficient structure. We could use some of the residual capacity within the foundations of the columns that support the capacity. So we didn't need any additional concrete in the ground. We didn't need any additional excavations. We didn't need to close the redway. And we actually looked at an overall reduction in the amount of steelwork within that building by achieving the cantilever detail. And that image there is a photo of the final building. So what you can see is that very closely followed the original architect's aspiration, creating a very, very striking building. And actually, it was just interesting to go through that collaborative approach very early on in the design stages there to actually say, no, it isn't necessarily the best way to achieve that cantilever by putting in columns and foundations. It's better to use the form of the building. We put in the diagonal members of the truss, and the only thing that we asked of the architect was that they actually worked their window layouts with our structure. So what you can see on the side of the lecture theatre is that they actually positioned their windows in and around our structure, which for them actually creates a nice little sort of random effect of the windows on the side of the building. So again, it's just flipping some of these problems on their heads, looking at things a little bit differently, a little bit more creatively, and realizing that actually by flipping things around and looking at things differently, there can be overall carbon reductions and reductions in the overall material within the building. So bringing in a slightly different take on the principles of lean design. The third and final project example I'm just going to run through here is a 15-story residential development within Manchester. The developer was Glenbrook, the funder was Moorfield. The design and build contractor was Graham's, and the architect was Shepherd Robson. We were the structural and civil engineers for this building. We actually were brought on by Graham during the tender process to actually work with them during the tendering process to actually look at ways that we could unlock value within the project, reduce material use, and see whether there were certain savings that could be realised before the final contract was signed. So we looked at the building, we said, you know, it's looking relatively well designed. There was an original structural engineer on board that had produced a tender scheme. But when we looked at it in a bit more detail, we realised that actually we think there is some saving that could be had within the concrete floor plate. So it was a concrete frame building with concrete flat slab floors up through the building. So we worked very closely with Graham's. And we said, well, actually, if we go through and we do some very, very detailed finite element analysis of each of these floor plates, we look at when the deflections will occur, we actually look at what the deflections are likely to be. We think there could be some savings. So we worked very closely with Graham's and with their construction program. And what we realized is that the floor plates themselves have been designed for a deflection limit. And that deflection limit was on the basis that when you strike these floors, they deflect. And that deflection needs to be accommodated within the cladding system itself. So it meant that the cladding system could only accommodate a certain amount of edge deflections, and those edge deflections, those limits were what were driving the thickness of the floor plates. So we worked very closely with Graham and said, well, actually, when are you going to put the envelope onto the building? At what point in the construction program are you thinking of actually putting the external facade in? When will the concrete frame be constructed? When will it be struck? How much of the dead load will actually be there? How much of the creep of concrete will have actually occurred? And what we found is that rather than edge deflections being a deflection problem, we could take some of that edge deflection out of the facade interface, turn that into a tolerance so that the facade fixings need to accommodate maybe a little bit more tolerance, but actually the deflection was reduced. And by doing that, we actually realized we could reduce the thickness of the concrete floor plates. It was a very modest saving per floor plate. We could shave around about 50 mil off per floor plate. But actually, by the time you take that amount of thickness reduction across 15 floors, it was a staggering reduction in the volume of concrete within the building. So what we found is that by reducing each of those floor plates by just 15 millimeters over 15 floors, we took just under 300 cubic meters of concrete out of the structure. And that isn't by looking at changes in the structure, changes in design codes or changes in the design nodes that we're doing. It was literally just looking at things in a slightly different way and working much closely with Graham's, with the contractor, to sort of understand what the construction program was. And it's staggering to think that actually that much reduction of concrete within the building itself is equivalent to driving, if you could do this, from Manchester to New York 53 times. So the equivalent of taking 3,334 car miles of carbon out of the building. And then there was the other aspect of that as well, which is that we actually reduced the construction vehicle movements within Manchester, and we actually took off just under 50 concrete lorries of construction vehicle movements off the streets of inner city Manchester during the build period for this building. So they're really just running through sort of 3 project examples just to take you through sort of some different aspects or some different principles of lean design. 2 other aspects that we are very keen on and we like to do again is raising awareness. We hosted our own event there just at the start of the year or the end of last year, just really to bring in some of the people that we work with, invite them in for a few drinks, a few nibbles, but really just take them through the principles of lean design, the principles that we're talking about here, and just sort of demonstrating as a structural and civil engineer, the amount of carbon, that 200 tons of carbon that we can reduce per engineer per year compared to the 2 tons just by cutting out meat and dairy. I mean, obviously we have to do all of those things. I'm not saying go out and ignore all of that other stuff, but actually doing everything in collaboration. So again, we've raised awareness, just talking to some of our fellow, our colleagues and some of our clients and architects, and sort of raising the awareness of how much of a carbon reduction we can make. The other thing I do as well is sort of getting involved in really grassroots education level as well. So I do a little bit of guest lecturing at Queen's. We set them there one of the modules is to actually set the design of a skyscraper building, and it's to sort of get the structural and civil engineers thinking a little bit more about the legacy that they're going to put in place, and thinking a little bit more about the type of building and the type of influences, that sort of maybe architects and other members of the design team need to think about. But actually, one of the other aspects we do is we talk about lean design. We talk about that it's not acceptable to over-design things anymore. It's not acceptable that things work just because they're conservative, but actually to think about that carbon benchmarking. And we introduce some material use and carbon reduction targets within the design brief so that they can actually look at ways that they can reduce the amount of material within their building. So again, it's getting in there at that kind of grassroots education level as well. And just getting there and just really raising the profile of lean design, raising the profile of material reduction, and that collectively we all need to work together to make a big impact on climate change and really reverse the climate emergency that we're in at the moment. So really, that's all from me. Thank you very much, as I say, for the invitation to present this webinar, and thank you very much for listening. And really, just go on to any questions you may have.
Thanks, Stephen. I think everyone will agree that was a very insightful and detailed presentation. We have several questions in already, so we'll get going. First question, do you think there is an opportunity for the engineering community within the construction sector to better understand how lean can be incorporated into the design process?
There is, yeah. I mean, at the end of the day, we get very frustrated because there is still a legacy where structural and civil engineers are not necessarily brought into projects early enough. We're sort of saying that the only way to unlock this lean design is to really get stuck into the client's brief, really interrogate the stakeholders, get stuck into the very, very earliest project stages. And unfortunately, there are still clients that see sort of maybe that sort of engineering input costs money until they've achieved planning. And the problem is that once a building achieves planning, you've locked in so many constraints. First one is you probably haven't even considered whether an existing building can be properly utilized or reutilized. I think there's so much that can be done. As an engineering community, we need to knowledge share, we need to learn amongst each other. There's lots and lots of webinars and various publications by the ICE and the iStructD that means that as engineers, we can learn off each other, but you also need to collaborate together and collaborate across our industries as well. So it's understanding much better how the M&E works within a building. It's understanding about how things are going to be built and looking at construction processes as well, because actually the construction process, construction sequence can have a big impact on the way things are designed and the way that we can actually unlock lean design and actually look at becoming sort of, less conservative in our designs at the end of the day. And I think, again, a lot of that is centered around partnerships as well. So, I sort of mentioned it a lot, but I think one of the biggest things we need to do is be absolutely transparent in everything we do, to kind of report on what we're doing, provide benchmarking on what we're doing, but really to collaborate as much as we possibly can at the earliest project stages. So I don't know, hopefully that's answered that question.
Yeah, I think so, that's great. Next question, what processes could be put in place to monitor and measure lean design?
Well, yeah, it's interesting. I mean, part of what I talk about there is sort of the carbon benchmarking. So when we're looking at lean design itself, I mean, the first one is to sort of look at the projects that, or the buildings that are there to start with and say, can we reuse? And if we can reuse, this is what the carbon reduction would be. something that we do within Design ID, and it's certainly something that's across the industry more and more, is to look at measuring the embodied carbon on buildings and actually presenting those in such a way that it can be measured and it can be followed. So it means that, as I mentioned a little bit early on in the design, in the presentation there, is that you have a benchmark of what the embodied carbon is within your structure, and then any design decision that comes out beyond that can show either a positive or negative impact on the embodied carbon within that building. So yeah, that's we've got to be transparent. We've got to provide that sort of benchmarking of embodied carbon. Embodied carbon and material reuse are probably two of the biggest ways of demonstrating that we are being as lean as we possibly can. And it's really just about looking at benchmarking against other buildings as well. So almost having a database of similar buildings, but also drawing on our own experience as well. So we know what slab thicknesses, for instance, we're expecting for certain spans of buildings. We know the design loads that we're expecting, that might fall out the client's brief due to the use of the building, and then going back and actually just interrogating the stakeholders and the client's brief as much as we possibly can.
Okay, perfect. Follow on from that, do you think clients understand lean and the value it can bring to their projects?
No, I don't think they do at the moment, and I think that's where something we really want to do is raise that awareness. We've started off by raising that awareness amongst our fellow engineers, but we need to go out and start raising that awareness. And what I think is very sad at the moment as well is that cost is very well understood. Cost and program are very well understood. And when a building is designed and it becomes over budget, clients are very, very quick to, look at value engineering, look at ways that we can actually reduce the cost within the building. And I think, we need to instill a culture of actually looking at the embodied carbon within the building as well. So again, a lot of that links into that scores rating that I sort of touched on earlier, which is where we're looking at the energy efficiency of the building. So, when we looked at things like BREEAM targets and things like that, BREEAM Excellent, there's a lot of focus in BREEAM on looking at sort of the M&E principles, the external envelope, the energy efficiency of the external envelope to actually achieve a rating of that building. And we really need to start trying to introduce those sort of measures and targets within embodied carbon as well. And as I did mention earlier as well, is what I think is a little bit sad that we need to push even further is that actually the principles of lean design, the principles of material reduction, not only they reducing the material in the building and associated embodied carbon, but more often than not, reduction in material use is actually a reduction in cost as well.
Okay, perfect. Another question from an attendee. What would you suggest will be key considerations for a client in the definition of scope and brief to establish and support a lean design approach?
That's interesting. I think it's, clients need to, it depends who the client is really. And a lot of clients are very, very well versed in providing briefs for certain types of buildings. So you may have a residential developer who's very used to this, is used to setting the client's brief. But I think it's about working very closely, with the design team at the very earliest stages, and actually saying, well, to develop that brief, what is it that they're actually looking for, and allowing the design team to respond to that. What type of building are they looking for? What type of use of building are they looking for? And letting the design team actually respond to that and provide what their sort of take on that is. Present back, go through sort of stakeholder engagement workshops, present what we think as a design team is our understanding of the brief, and making sure that ties up with the client's aspirations as well. But I mentioned it before as well, there really is value in having sort of a all-encompassing design team involved at the earliest project stages, where we can all collaborate, we can all question the client's brief, and we can effectively produce what is, a more cost-effective building. There's so many buildings that I've been involved in previously where, as I say, the structural engineer's involvement hasn't happened to post-planning. I've been involved in an education building, for instance, where the building looked fantastic, the internal spaces were fantastic. The building had gone to planning, the height of the building had been set, which meant we were left with extremely tight structural zones within the floor to incorporate our structure. And actually, by looking at the embodied carbon that was associated with that structure, was far more than it would have been if we'd have been involved at the earliest project stages. And that material use equates to cost as well. So I know we would have produced a more cost-effective building if we weren't so constrained by planning conditions. Would have been involved much earlier in the design process.
Okay. Another question in, do you think that the implementation of lean design could lead to a reduction in structural lifespan?
No, and no, I don't think it could. And the reason why I say that is because, and I tried to sort of emphasize it within the presentation as well. We're not talking about going outside of design codes. We're not talking about reducing design loads below what is recommended within the design code as well. We're not talking about utilizing members greater than the design code recommends. When you design a building, for instance, a concrete frame building, more often than not, we're designing to the Eurocodes that dictates that building is designed for a lifespan of 50 years. That's very typical. And that 50-year lifespan means that we follow all the principles within the design code, and it will have a 50-year lifespan. What I'm talking about with the principles of lean design is actually looking at getting closer to the utilization of one within the structural members themselves, and actually just taking out that conservatism more than anything. And that conservatism means we design more leanly, we reduce material, and we reduce embodied carbon within the building. So no, the principles that I'm talking about here and wouldn't affect the design life of a building.
Okay, just to let you know, we're getting some great comments in relation to the presentation, and out of the box thinking has been a comment from one attendee. Another question, do you think a change in procurement and contracts to a more collaborative effort would help the Lean Green initiative?
Yes, I do. I do think that, yeah. I think the problem is with contracts, and it really depends on the type of contracts. We're probably well experienced in the likes of public procurement contracts, where we're probably experienced in the likes of NEC contracts and different forms of procurement. But I really think that it depends a little bit on what the building is and how complex it is as well. But I think in terms of procurement, I like design and build contracts because it gives us the opportunity to work very closely with the contractor. As I mentioned there on the Cornbrook project, we worked very, very closely with Graham's to sort of work in partnership with them and bring in their knowledge and experience, bring in their their program, the construction program, to be able to unlock real savings within the structure itself. So I think there needs to be changes to procurement and contracts to really centre more around a partnership, to take away the sort of the litigious side. Obviously contracts are there to control problems, but I think that if we have a more transparent version of contracts, that means that we can be much more upfront and honest, and we can be more honest about where the contingencies are as well. It means that we can have a much more partnered discussion with the people we're working with. Flip side of that again as well, that I sort of touched on, was that I think it would be great within, say, public procurement contracts at the earliest stages that we actually include carbon benchmarking in there as well, so that as we go through the design process, as we go through the tendering process, there's lots of incentives there to actually reduce material use. And again, this sort of ability to tap into maybe the contractor's experience on ways to build things.
Okay, great. Another couple of questions. Just we have a few minutes left, so if there's any more questions, just put them into the question pane for Stephen. How can we change design culture when the nature can be to be conservative to avoid criticism or worst case litigation?
I know, and I've sort of touched on that with some of the other answers to the questions as well. I mean, the culture is, there is a culture that we be conservative, and we're pushed into that, I suppose, a little bit, because there is a fear of change, there is a fear that when things go wrong, there is that blame culture. So a lot of the things that I talked about in the other questions about maybe more of a partnering contract, being more transparent with where we're how we're designing things. So having a culture where we design to a unity of one, and then say this structure as it stands, as it meets the brief as it sits at the moment, is as efficient as we can possibly make it. You've got to realize if you make a change now, if you change the column grid, there will potentially be implications, but it means you can respond to those implications within a sort of a contingency, as opposed to engineers going in and actually including their own design contingencies to try and respond to that change. So it's just being much more transparent. And again, I think that, you know, if there can be cost and program contingency built in as well, it means that we can be much more efficient in our design. And if we do have to make a change because we're responding to a change or things do get slightly different, it actually comes out of a very transparent pot of money and program contingency pot, as opposed to this blame culture and pointing fingers. There's a lot of work still to be done on that, though.
Okay, I have one more question. I think you may have covered some of this, but at what stage in the design and construction process are the principles of lean design most beneficial?
Right at the beginning, right at the very beginning. You know, we have to be involved at the earliest project stages to really unlock so much potential, and that comes sorry, excuse me, that comes right back to the yeah, the earliest stages of the project, when we're looking at a client has got a brief to provide 2,000 square meters of lettable commercial space. How can that be achieved? It's not about us coming in once the site has been set, once the building form is in place, once some discussions have started with the planners, for instance, where we're starting to get tied into a form of building, a position of the building, a location, but actually looking and saying, well, you know, as a client, do you have existing building stock? As I mentioned on the Weaver's Court project, there is an existing building there. Can we bring that back into use? Let's get involved at that early project stage, and yeah, so whether we can bring that building back into use, and then start to you know, progress the discussions with the planners and that sort of thing. So the most benefit, and particularly if we're looking at refurb or reuse of buildings, is at the very earliest project stages. I say that though, we can be involved in any stage of a project and guarantee that there will be savings that could be had. Cornbrook is an example where, you know, it's already gone through to the tender stage, and there was quite a significant saving that could be had. You know, so I'd say at any stage, reductions can be made. To get the biggest impact, is to be involved at the earliest project stages.
At the start, yeah. Okay. Okay, we're just out of time now. Thanks a million. I'd like to thank Stephen again for his presentation today. A copy of this webinar will be sent out to everyone who attended. We will send out the information shortly via LinkedIn, Twitter, and newsletter for the next webinar, which will take place on the 23rd of February. Thank you again from Stephen and myself on behalf of Lean Construction Ireland. You can follow Lean Construction Ireland on LinkedIn, Twitter, Facebook, and through the website leanconstructionireland.ie. Enjoy the rest of your day. Thanks again, Stephen.
Thank you very much. Thank you.